Hello class, so this is my quickly made video about SOH CAH TOA. There are probably better ones online if you want to use those, do so. But your main thing is that you need to know what your formulas for these are. So this would be sine of theta, so, is equal to the opposite over. Then the cosine is, C stands for cosine of theta, is equal to the adjacent over the hypotenuse. And then tangent of theta, or the T stands for tangent, is equal to the opposite over the adjacent. So write these down. I'm going to clear the screen. So really, you need to understand very well what we mean by all these things: opposite, adjacent, hypotenuse. So the hypotenuse, if I spelled it wrong, I apologize, definitely not my main thing. So key things about the hypotenuse: it will be the longest side, and its opposite, or cross opposite, from the right angle. Alright, then we want to say, okay, so if we have some theta or some angle, theta is a stand-in for an angle, what would be my adjacent? So when we talk about adjacent, we mean a side that is the same, this is the hypotenuse side, a side that's next to our angle, but that's not the hypotenuse. So adjacent would be a side that's right next to it, the side next to your angle. That is not already your hypotenuse. So this is not your hypotenuse. Alright, then we want also the opposite. So the opposite is the only side that's not touching your angle. So this would be the opposite side. So it's not touching your angle. Alright, so using this, let's solve some problems. So let's say you have some force, hypotenuse, that's 12, and you want to know what the x and y components of it are. You want to know what the opposite and the adjacent angles are, or sides, and you know that the angle here is 40 degrees. So how could you find both the x and the y side of these? Well, let's think. We have sine of theta, cosine of theta, tangent of theta. Each one is equal to, so this is opposite over hypotenuse, this is adjacent over hypotenuse, and this is opposite over adjacent. I would definitely always write these down on your paper so you make sure you know them when you're doing your problems. So let's figure out what y is. Let's focus on y. So to figure out what y is, notice it's y's position. It is not next to, it is opposite of our angle. So y is your opposite. Alright, then obviously our angle is our 40 degrees, and our hypotenuse, sorry, I should have drawn that right angle there, our hypotenuse is 12. So if we have the opposite, the hypotenuse, and our angle, you're going to want to use sine. So we do sine of 12 is equal to the opposite, which is your y, over your hypotenuse, which is 12, oops, sine of 40, I thought something sounded wrong there. Excuse me, sine of 40, because that's your angle. So it'd be sine of 40 is equal to y over 12, your hypotenuse. You'd solve this by multiplying 12 by both sides. It'd be 12 times sine of 40 is equal to y. Plug it into your calculator, and you would get y to equal 8.9. Alright, then to find x, let's switch colors to orange. So x, notice x is right next to your angle. So to find x, what you would need is, alright, if this is now adjacent, it's right next to the angle, so we have the hypotenuse and the adjacent. This would lead to us to be like, okay, so now we can use cosine. So you'd set the same thing, it'd be cosine, which is of 40, our angle. It'd be adjacent, which is our x, over the hypotenuse, which is 12. So again, it would be 12 times cosine of 40 will give you x, which is 9.19 is equal to your x. And I apologize for all of you who were doing it with me and were confused. I checked my calculator and it was accidentally in radians when I did this, so I went back and it's the same thing, but just make sure that every time you're in it, your calculator says DEG or degrees at the top, otherwise you are doing it incorrectly. So it would be 7.71 would be your answer for the first one. So I want you to try one on your own. So let's say we have some force that's being pushed up and to the left at a 30-degree angle. So that's 30 degrees here. At a 30-degree angle. And I want to know what my x component is and what my y component is. I know that the total force pushed at that angle was 20 newtons. So try to figure out, right, go ahead, pause. Remember your angle is 30. Your force in that direction is 20 newtons. So notice what's happening when you do these. You make your own right triangle, and then you have to find each side to figure out the x and the y direction. Because remember, we want to break every force problem into only the x and y. So pause it and try to figure out what x and y are. Alright, so I'm going to solve for y first. No particular reason. So y is the opposite of your angle. So that means y is the opposite. Your angle is still 30 degrees. And your hypotenuse, which is your original force, is 20 newtons. So if we have opposite and the hypotenuse, again, that means we're going to want to use sine of theta, which is equal to the opposite over the hypotenuse. So it'd be sine of your theta, which is 30, your angle, is equal to the opposite y over your hypotenuse, which is 20 newtons. So you'd multiply both sides by 20 newtons, so it'd be 20 times sine 30 gives you y. Solve for this. Make sure your calculator is in degrees. After you do this, you should get a really nice number, which will be 10. Notice, though, we're talking about forces, so the force up in the y direction would actually be 10 newtons. It has a direction, which is force in your y direction. So if you want to go back and figure out why we're doing this, think about it. It's force in the y direction, so now we can go back and find x. So x, I'm switching to black. So x is, think about it, this is still our angle. If you really wanted, you could find this angle and then do sine again, but it's no point. Extra work, in my opinion. You could do, x is now next to your angle, so this is an adjacent angle. Your theta is still 30, your angle hasn't changed, and your hypotenuse is still 20. So now you're going to set the same equation, except with cosine of 30 is equal to opposite over adjacent, which, or not opposite, excuse me, adjacent over hypotenuse. So that's cosine, so it'd be x over your hypotenuse, which is, again, 20 newtons. So it'd be 20 times your cosine of 30. Always check that you're in degrees, will give you your x. And if you solve this, x will then equal 17.3 Remember, we are talking about forces, so newtons in the x direction. And technically, this is going left, so this would generally be considered negative newtons. Alright, hopefully you now understand why we need to solve these for our force equations. A lot of times you'll have multiple things going in different directions. You're going to have to figure out the x and y so that you can now go back and add and or subtract them. We'll be continuing with these tomorrow. Have a good afternoon.